Venn diagrams and two-way tables. What are they used for? Venn diagrams and two-way tables are used to represent events, help visualize probabilities, and assist us in solving probability questions. Okay, let's have a look at an example using a Venn diagram. A group of Year 10 students were interviewed and asked if they liked cats or dogs. Below is a summary of their responses. 15 liked only dogs, 8 liked only cats, 2 did not like either, and 3 liked both cats and dogs. Fill in the Venn diagram and answer the following questions using the Venn diagram. So if we look at our Venn diagram, we have two headings, dogs and cats. Now each circle represents either dogs or cats. The circle on the left represents everyone who likes dogs, and the circle on the right represents everyone who likes cats. The part in the middle where the two circles overlap, that is where you would have people who like both dogs and cats. And outside of the circle, you would put anybody that doesn't like cats or dogs. So let's have a look. The first one is 15 people liked only dogs. So that's going to go in the part of the circle that is just for dogs, not the overlap part. The next one is that 8 people liked only cats. So that's going to go in the cat circle, but not in the overlapping part. 2 did not like either. That goes outside because it's not in either of the circles. And the last one of 3 liked both cats and dogs, that goes in the middle, in the overlapping part. If we have a look at the questions down the bottom, we have how many Year 10 students were in the group? So remember we were told in the question that a group of Year 10 students were interviewed. So how might we work out how many students were in the group? Okay, so we will add up all of the numbers in the Venn diagram, and that will tell us how many people were interviewed. So we have 15 plus 3 plus 8 plus 2, and that equals 28. So there were 28 Year 10 students in the group. Question 2. If I choose a student at random, what would be the probability that they liked only dogs? So if we go to our Venn diagram, how many people liked only dogs? We would be looking for the part of the dog circle that doesn't overlap. Okay, and that would be 15. Now when we do a probability, we have to have our favourable outcomes and our total outcomes. Now our total outcomes would be 28, so the probability of a student being chosen at random that liked only dogs would be 15 over 28. Question 3. If I choose a student at random, what would be the probability that they did not like cats or dogs? So once again, we go to our Venn diagram, and this time we're looking for people who are not in either of the circles because they do not like cats or dogs. So that would be 2. And once again, we have to put that over our total number of outcomes, and we would have 2 over 28. Okay, let's have a look at another example. 25 people were asked if they play soccer or netball. Their responses are below. 10 played netball, 5 played neither sport, 8 played both sports. Fill in the Venn diagram and answer the following questions. We can see from the information we've been given that we haven't been told how many people played soccer. So we're going to have to work out some of the numbers. Let's start with the information that we do know. We know that 5 played neither sport, and we know that in the Venn diagram that goes in the outside part outside of the two circles. So we have 5 out there. We also know that 8 people played both sports. Now we know that in a Venn diagram that goes in the overlapping part in the middle, 8. Now, the only other piece of information we've been given is that 10 people played netball. Now, that doesn't say that they just played netball. It says that they played netball. So we need to assume that that also includes the 8 people that also played soccer. So we need to only have a total of 10 in our whole netball circle. Now we can see we've already got 8 people here that play netball and play soccer. So what's going to go in the other part of the circle? The people who just played netball, if we know that the total circle has to equal 10. That's going to be 2. Now from here, how are we going to work out what goes in the soccer circle? Well, we know that we should have a total of 25 people because the question said 25 people were asked. So 2 plus 8 equals 10, plus 5 equals 15. So we're missing some people out of our Venn diagram because it has to equal a total of 25. So that tells us that the remaining 10 are the people who just played soccer. So that goes in that part of the Venn diagram. Now let's answer the questions. Question 1. If a person was chosen at random, what is the probability they play soccer? Now it doesn't say that they play only soccer, it just says that they play soccer. So if we look at our Venn diagram, we can see we have 10 people that just play soccer, but we also have 8 people that play soccer and also play netball. So we need to include them. So we have 18 people in total that play soccer. Now remember, when we're doing a probability, we're going to do it as a fraction and we're going to do our favourable outcomes over our total outcomes. So we will have 18 over our total of 25. Question 2. If a person was chosen at random, what is the probability they play both sports? Once again, we'll go to our Venn diagram and we can see that the people who played both sports, there was 8. So our answer to question 2 will be 8 over 25. Okay, now we're going to have a look at two-way tables. We're going to use the example we used in the previous Venn diagram example. So 25 people were asked if they play soccer or netball. Their responses are below. 10 people played netball, 5 played neither sports, and 8 played both sports. Fill in the two-way table and answer the following questions. I've already put in the numbers that we know. We know that we had a total of 25 people that were asked. So 25 goes in the bottom right-hand part of the table. We know that 10 people played netball. So in our total column, in the row that says played netball, we have 10. We know that 8 people played both sports, so we find the part of the table that has plays soccer and plays netball, and we put 8 there. And then we know that 5 people played neither sport, so we find the part of the table that says does not play soccer and does not play netball, and we put the 5 there. As you can see, we have a lot of question marks or blanks left in our table, so we need to fill those in. The way we do that is that we remember that we have total columns. So the other columns have to add up to the total columns. If we look at our final column on the right, the total column, it says 10 question mark 25. Now what that means is 10 plus something, or the question mark, equals 25. Now the question mark will be 15 because 10 plus 15 equals 25. If we go to our top row, plays netball, we can see that we have 8 plus something equals 10. Now that tells us that our question mark would be 2 because 8 plus 2 equals 10. Now that we've got that 2, we can do our does not play soccer column. Okay, and we have 2 plus 5 equals 7. Now we can do our column that says does not play netball, we have something plus 5 equals 15. And that tells us that that part of the table has to equal 10. And now we have all of our parts of the table except for one, and this bottom one is the total amount of people that play soccer. So if we look at that plays soccer column, we have 8 plus 10, which will equal 18. Now that our table is filled, we can answer the questions. If a person was chosen at random, what is the probability they play soccer? So we look at our table and we find the people who play soccer. So looking in the column that says plays soccer, we can see that the total is 18. So the total people that play soccer is 18. And to write that as a probability, we do our favourable outcomes over total outcomes. So we will have 18 over 25. For question 2, if a person was chosen at random, what is the probability they play both sports? Now we need to go to the part of the table where they play both sports. And we can see right at the top, we have plays soccer and plays netball. And that part is number 8, okay? Or there's 8 people that play soccer and netball. So once again, because it's a probability, favourable outcomes over total outcomes, and we will have 8 over 25. Now we're going to do a final example using a two-way table. So here we have a two-way table that has been partially filled, and it's about people who like lollies, like chocolate, or don't like lollies and chocolate. Now when you are given a partially filled table, you need to fill in the blanks, or in this case we have question marks. And the way I do that is that I look for columns or rows that are only missing one value. So if we look at our last column, our total column, we can see that we have 20, question mark, and 50. So that means that 20 plus something will equal 50, because 50 is in the bottom and that's the total of the whole table. And we know that 20 plus 30 equals 50. Now let's look for another blank. If we look at the row that says like lollies, we can see we have 10 plus something equals 20. And that something will be 10, because 10 plus 10 equals 20. Now if we go to the next row, we can see that we have something plus 12 equals 30. And that's going to be 18. Now if we have a look at our final part of the table that isn't filled in, we can use the does not like chocolate column, and we can go 10, because we already know that number, plus 12 equals 22. And we can check by calculating all of our numbers to make sure they equal 50 along the bottom row and the final column. So we can see that the total row down the bottom, 28 plus 22 equals 50, and then coming down the last column, 20 plus 30 equals 50. So it balances. Now let's answer the questions. How many people like lollies but do not like chocolate? So if we go to our two-way table and we find the row that says likes lollies, and we come across that row to the column that says does not like chocolate, and that part of the table tells us 10. So 10 people like lollies, but they do not like chocolate. Question 2. If a person was chosen at random, what is the probability that they would like both lollies and chocolate? Now this question wants to know the probability. So we're going to have to give our answer as a fraction or a decimal, okay? We're going to give it as a fraction. So how many people in the table like both lollies and chocolate? Well, if we go to our likes lolly row and come across to the column that also says likes chocolate, we can see that we have 10 people that like lollies and like chocolate. So favourable outcomes over total outcomes, will be 10 over 50, and when simplified that equals 1 over 5.